Hello and welcome to the course on microwave and antennas. In this lecture, we will learn about microwave systems. We have studied about various microwave devices in previous session. Example, signal generator, amplifier, filter, mixer. Now, what is a microwave system? We are going to put together microwave devices to design a useful application. This is a microwave system. Now say you want to design a communication system. It could be a radar, a satellite system, or a mobile communication system. A high-level block diagram looks something like this. There are two major blocks here, the transmitter and the receiver. Since the microwave communication is a wireless system, we need some way to take out the signal from the transmitter and send it to the receiver over the air. So this is done by the transmitter antenna on the transmit side and receiver antenna on the receiver side. Now let us get deeper into a microwave system. So what does a transmitter and a receiver consist of? Let us start with the transmitter. We all know that if we are considering a mobile communication system, our voice simply cannot be transmitted wirelessly to another mobile phone. First, generate the signal. Then use a mixer to convert this voice frequency, which is at low frequency like 1 kHz or so, and then up convert to a microwave frequency, say for example 1 gigahertz or so. This is done by a mixer, but mixer also needs a carrier signal to be generated. This is done by a signal generator, say for example an oscillator. This is called as a microwave source. Remember that in practical systems nothing is perfect. So obviously the source is not only giving 1 gigahertz signal but also other unwanted frequencies. Now you want to ensure that strictly whatever the frequency assigned for your system transmission only is sent and nothing else. In this case, this frequency is 1 gigahertz. So what you do is put a microwave filter after the source to remove unwanted frequencies coming out of the source. So in this case, it is a band pass filter which allows only 1 gigahertz signal and eliminates all other unwanted frequencies at the output. Since the output of signal source and subsequent filtering operation has reduced the signal power, we will boost it by passing through a microwave amplifier. In case the signal is too high to be transmitted, then insert a calibrated attenuator. A microwave attenuator by nature provides microwave signal attenuation without distortion. Attenuation implies reducing signal power. So attenuator reduces the signal power while amplifier increases the signal power. This attenuator is calibrated to ensure that signal attenuation is exactly as needed and not more or less. Example, if we want the signal power after the amplifier, say which is 1 watt of power comes out of amplifier, and if we want it to reduce it 0.5 watts, then the attenuator should exactly reduce the power by half. So finally, this signal is sent to an antenna for transmitting towards the receiver. This antenna could be a horn antenna, a dipole antenna, or some other antenna type based on application. Antenna is a huge topic for discussion and we will cover that in future sessions. Now notice two things here. One is this red line that you see here connecting the devices. This could be a waveguide or coaxial cable or simply a transmission line. We will discuss about transmission lines in future sessions. For now, think of this red line as a way to connect different microwave devices such that signal passes from one device to the next device. Notice another thing here which is referred as wave meter. As mentioned before, we want to transmit only the desired frequency, say 1 gigahertz in this particular example and nothing else. So wave meter is an external device which measures the wavelength of the signal passing through the red line or the transmission lines. We know wavelength and frequency are related, so we can determine frequency that is passing through the system using this wave meter. Now the signal has arrived at the receiver. So obviously the first microwave device is a microwave receiver antenna. Since antenna, unlike a filter, cannot be designed to receive only the desired frequency which is 1 gigahertz, it receives lot of other unwanted frequencies. So let us place a band pass filter like before to remove unwanted frequencies from entering the receiver system from air. As the microwave signal has traveled a long distance from transmitter to receiver, its power level has dropped significantly. So we need to amplify the signal. So what do we use? We use a microwave amplifier. But compared to the amplifier on transmitter side, this is a bit different. Here it is called as a low noise amplifier or LNA. This is because the signal power received at receiver is very low. So let's take an example. Say if the transmitted power from the transmitter is zero point 0.5 watts, then the received power at the receiver here could be in the range of 10 to the power of minus 9 watts. So it is 1 nanowatt of power is received at the receiver. So if you draw the signals, so this could be your transmitter signal and received signal could be like this. It's a very low power signal. So we want the receiver to amplify this low power signal, but this amplifier should not add its own noise. Since all electronic devices including amplifiers inherently add noise, so here we need a low noise amplifier, which means it adds very less noise to the signal. So noise is a huge topic, so you may read about noise sources like thermal noise, short noise and so on. Finally, we want to check how the received signal is after passing through all these operations. So use an oscilloscope if you want to check the time domain signal shape, or use a power meter to just note down what is the received signal power if you are not bothered about the signal shape. If you want to see the signal shape in frequency domain, then use a spectrum analyzer. So use an oscilloscope for time domain analysis and use a spectrum analyzer for frequency domain analysis of the signal. Spectrum analyzers are commonly used measurement equipment in microwave engineering.